Hey everyone, welcome back. John Oden on the development team here at Boson Software. In this video, we're going to do a walkthrough of the first demo lab that comes with Boson Netsim 12. In a previous video, we went through the process of downloading, installing, and activating Boson Netsim 12, which is our new major update. So you can go back and look at that video to see how to get to the point that we're at right now. At the point that we're at right now, we have Netsim up and running on the screen. And you can see by the login ID, which is my email address in the upper right-hand corner, that we are actually logged into Netsim. Now, this particular account that I'm logged in with has not made a purchase yet, and as such, we're operating Netsim in demo mode. So if you look at the lab tree, this is a list of all of the lab exercises that come with Boson Netsim. There are over 300 of them altogether. And you can see that most of them have the lock icon to the left, and that indicates that those labs are not accessible to us because we've not purchased a license for the version of Netsim that gives us access to those labs. But even in demo mode, having made no purchase with the account that I'm logged in with, we have access to these 4 labs up at the top, and we're going to walk through the first one. Now you'll see a red X beside the first one, and that's a new feature that we have introduced with Boson Netsim 12, which is one of several things that we have that will help you track your progress as you work through the labs in Netsim. That red X indicates that I have attempted that lab, but I have not worked through it to a successful completion. So that's what we're going to do here in this video. So the first thing I need to do is to get that lab loaded into the simulator. So to load any lab into the simulator, first you have to make sure that you have access to that lab. In other words, you have to have purchased a license for the version of Netsim that gets you to the lab that you want to use. For example, if you have purchased the CCNA version of Netsim, you're not going to have access to the route switch and T-shoot labs because those only become available when you purchase the CCNP version. So we're going to do a demo lab which is available to anyone that downloads, installs, and activates Netsim. And again, go back and look at our previous video and you'll be able to see how to do that. So I'm going to give a double click on this first lab, and when the lab loads into the simulator, a few new elements of the user interface will appear. The first of which is the lab documentation. You can look up here at the top and see that there's a very detailed document that gives an introduction to the lab. It sets forth the objective. It describes the lab topology that we'll be working with. We have a list of all the commands that we're going to need to use to work through the lab. Then we have a table of IP addresses and the devices and interfaces that they should be applied to. And then we have a series of lab tasks that we'll need to carry out to meet the objective of the lab. And then there'll be some confirmation steps at the end to verify the fact that we have worked through the lab successfully. And I'll also show you that Netsim includes a grading feature that will allow you to check your work. So let's go ahead and keep looking at some of the new features here. Just very quickly, I want to let you know that if you have multiple monitors, you have the ability to take most any aspect of the Netsim user interface and pop it out into a floating window. So for example, if I wanted to do that to the lab document, I could right click on that tab and choose float, and that puts the lab documentation in a floating window. And I could do the same thing with the console window down below. I could right click and choose float, and now both of these elements of Netsim, I could move them to other monitors if I had them. I could rearrange them on the screen to suit my preference so that I can work most effectively. So this is the console for router A. If I tap the enter key, you'll see that we get a response back from the device just as if we had a console cable connected to the console port on that router, connected to a laptop with terminal emulation software running on it. Now, since we only have the one monitor for the purpose of this video, I'm going to go ahead and put these elements of the user interface back in their docked position. And to do that, I can just right-click and choose Dock as tabbed document, and they'll go right back where they were. Another element of the user interface that I'd like to show you is the lab topology diagram. Now, we saw a static version of this in the lab document, but this is a dynamic, clickable version of the lab topology. And we can do a number of things with it, but the first thing that I want to show you is the fact that we can use this topology diagram to open up additional console tabs to access the consoles of as many of these devices as we wish. You can see I've already got a console window for router A, but if I wanted one for router B, I can just double click and there it is. That's router B. If I wanted to do that for one of the PCs down below, I can double click on it. And now I have a command window that gives me access to the command prompt to PC 1. And with those multiple console windows open, I simply click on the tab for the one that I want to work with, and I can instantly go from the console of one device to the other. Now in this particular lab, the lab documentation tells us that everything in this topology is configured except for router A. Router B, the two switches, all four PCs, they are all configured. Router A has a blank configuration on it, which would be just as if you took a real piece of hardware and powered it up with no config. It'll come up in its default state, and that's exactly where router A is right now. We get a hint to that in that the command prompt is the default of router. It's not identified with a host name as router B is. So following along in the lab documentation, the first thing that we're going to do is to put a host name on router A so that we can keep up with which device it is. And to do that, the first thing we're going to do is to go into privileged exec mode with the enable command. And then from there, we'll go into configuration mode. And as soon as we go into configuration mode, we get a console message that reminds us that we are evaluating Boson Netsim in demo mode. And therefore, we're going to have access only to a very limited command set that gives us access only to the commands that are necessary to run through this particular lab. So as you purchase a license for the version of Netsim of your choice, then the lab content and technology will be updated or unlocked according to the version of Netsim that you've purchased. So we're going to stay in demo mode. That's just fine for what we're going to do now. I'm going to use the hostname command to identify this as router A. I'm going to do a show IP interface brief, and notice that I can use command abbreviations. I can use the tab key if I wanted to for command expansion, just like that. I can also use the question mark help to see what options are available at whatever command level that I'm at. So let's do show IP interface brief. And we can see that all of the interfaces are shut down, and there are no IP addresses assigned to any of the interfaces. So that's the first task in the lab, is to configure this interface here on router A that connects across the WAN to router B. Now for this lab, we are using a serial link. Now I realize that we don't use those too much in the real world anymore, although there are some, but often serial links are used in a back-to-back configuration in a hardware lab, and that's what we're doing here really, but in a simulated version. So router B is already configured on its end of the serial link. We're going to configure router A. Now, this is a point-to-point link, so we only need 2 IP addresses, and our lab documentation tells us that this is the 10.114/30 subnet, which gives us host IPs of 10.1.1.5 on the router A end, and 10.116, which is already configured on the router B end, and we'll use a subnet mask of 255, 255, 255, 252 on both ends. So let's go ahead and get that set up. Okay, so I'm back in config mode, and from there I'm going to go into interface config on interface serial 0. And I'm going to apply an IP address of 10.1.1.5 with a /30 mask, which in decimal is 255, 255, 255.252. The lab document also tells us that router A is the DCE end of this serial link. So as a result, we're going to need to use the clock rate command to set up clocking on the router A end of this serial link. So let's go ahead and do that now. Okay, and that should complete the configuration of serial 00 on router A. So let's leave config mode and do another show IP interface brief just to review our work. And we can see that we have successfully assigned the IP address of 10.115 to serial 00 on router A. Now the interface is still down, so there's one more thing that we need to do. We need to go back into interface configuration mode and issue the no shut command to bring the interface up. We've done that. The console messages confirm that the status of the interface has changed to up with the line protocol status of up. And another show IP interface brief confirms that. So let's go ahead and test this serial link by issuing a ping from router A to the other end of the serial link over on router B. So we're going to do ping 10.1.1.6 from here to over here, and we see that we get successful replies. So we have successfully completed and verified the first task in the lab, which was to get the serial link between router A and router B, moving traffic between those devices, and now we've done that. So task 1 is complete. So the next task is going to be to configure the LAN interface on router A. Router A has 2 interfaces, one connected to the WAN going across to router B, and another one connected to the LAN via switch A to provide connectivity to the 2 PCs down below. Now, the lab documentation reminds us that the way these LANs are numbered is that this office location on the left, if you want to think about it that way, the LAN is in the 192.168.100.0/24 subnet, and the LAN over on the right side, network B, in location B, is in the 192.168.200.0/24 subnet. You can take a look at the lab documentation and it will confirm that. In fact, we'll go take a look at that right now, and we can see that in the network topology diagram where we have the IP addresses of all of the devices. And we won't be needing the lab topology to click for any reason for a bit, so I'm just going to leave it on the lab instructions so we have that diagram up there to refer to. So our next task is going to be to go back to router A and go into interface configuration mode and put the IP address of 192.168.100.1 on fast Ethernet 00. Okay, we're in interface configuration mode, fast Ethernet 00 on router A. So let's go ahead and apply the IP address of 192.168.100.1 with a decimal mask of 255.255.255.0. This being an Ethernet interface, that's really all the configuration that's required in this fairly simple example. So I'm going to do a no shut, and let's verify that the interface does come up, and it does. That verifies that the cables are plugged in and everything is good. So we should now have connectivity between router A and switch A, and then from switch A down to the PCs, and we'll configure that. But first, let's do another show IP interface brief and examine the output and make sure that we do have 192.168.100.1 configured on fast Ethernet 00, and we do. And we want to make sure that the interface status is up, and it is. Now, PC1 is already configured to have its default gateway to be 192.168.100.1. So this PC here is going to use router A as its default gateway if it needs to send traffic to a network other than the 192.168.100 network of which PC1 is a member. So our first confirmation step is going to make sure that we can ping the default gateway from PC1. So here we are at the console of PC1, and let's do a ping, and we get successful replies. So up to this point, we have configured the interface on router A to move traffic across to router B. And we've also configured the fast Ethernet interface on router A to communicate through switch A to the PCs in network A. So remember, the objective of this lab is to make sure that we have end-to-end connectivity across the network. So we know we've got connectivity from PC1 to router A, but what if we tried to ping 192.168.200.2 over in the other office location, over in network B, at location B, if you want to think about it like that. So we're on the console of PC1, and we're issuing a ping to 192.168.200.2, which is the IP address of PC3. So let's give that a try. Okay, we can see that that was not successful. Somewhere along the way, traffic is not making it to router B. Now, from the lab documentation, we've been told that the only device that we need to configure is on router A, so the issue must be on router A and its configuration. So let's go over there and take a look. So if we put our troubleshooting hats on just for a moment, let's go to router A, and the first thing I'm going to look at is to examine the IP routing table. So I'll use the show IP route to do that, and I start to get a sense of what the problem might be because router A only knows about the networks that it's directly connected to. Router A knows about the 192.168.100 network. It knows about the 10.114 point-to-point network between router A and router B, but it doesn't know anything about 192.168.200. It doesn't have a place to send that traffic, so it drops it. And that's why our pings are failing. So if we look at the next task in the lab, we're going to be asked to solve that problem. Now we could solve it a number of ways. We could do some static routing, or better, to use a dynamic routing protocol. And in this case, we're going to use the dynamic routing protocol EIGRP. And the lab documentation tells us that EIGRP is already configured on router B, so we need to configure EIGRP on router A using the autonomous system number of 100. So let's go ahead and get that done. So the first step to do that is to issue the router EIGRP 100 command, and 100 is the autonomous system number that we're using for the EIGRP process that we're setting up, and that matches the autonomous system number for the EIGRP process that's already running over on router B. So with that done, then we need to advertise the networks that are directly connected to router A. So let's go ahead and do that. So router A is connected to the 10 network across the WAN link. And we can see from the console message that router A has found an EIGRP neighbor, and they have established an adjacency between them, and now they'll start exchanging information about the networks that each other knows about. So in my next command, I'm going to, on router A, advertise the 192.168.100.0 network. And now with that done, let's go back and examine the IP routing table again. We can see that we've got information about a new network here. We can see that router A now knows about the 192.168.200 network, and the legend in the IP routing table, the C's indicate directly connected routes. The D indicates a route learned via EIGRP. And router A learned about that network via 10.116, which is reachable via the serial 00 interface on router A. So let's go back and try that ping again. Remember where we were before. We were over on the console of PC1 attempting to ping PC3. Oh, I'm just going to hit the up arrow to repeat that command, and we can see that we now have success. Now that we have configured both of these interfaces on router A and tested them independently, and then finally we established an EIGRP routing process on router A so that router A and router B can exchange information about their directly connected networks. When EIGRP converges, there's full reachability from any point on this network to any other, and we just confirmed that. So the next thing that we should do is to use the grading function that is a part of Boson Netsim to check our work in yet another way. We have verified our work using network diagnostic commands, ping and examining the IP routing table. Those are some of the tools that we used to identify and confirm full reachability through the network. But Netsim also has a grading feature. So I'm going to go up under the main menu and choose Lab and then Grade Lab. And the dialog box is telling me that we have completed the lab successfully. We'll click OK to look at the results. And across the top here, I can see first a summary. This is the name of the lab, the email address that I'm logged into with, and the result, which is that we have a successful completion of the lab. And then we can look through the output of the grading module, and there's a green check mark above each device, and we also have a display of the configuration on each device. And if there was a problem with our work on router A, or if there's a problem with any of the devices in the network, we would see some colored highlights that would tell us that either there's a command there that shouldn't be there, or we've missed a command that should be there. So in this case, we've worked through everything correctly, and we have verified and we have successfully completed this lab. And now that we've done so, notice that that red check mark that was there before, which indicated that I had attempted the lab but not completed it successfully, has now changed to a green check mark, which is my additional confirmation above and beyond the diagnostics that we did. This is the grading function confirming that I have successfully configured everything in the lab. So that's a walkthrough of configuration demo 1. You can go to our website, boson.com, And if you haven't already, go back and check out our other video. I'll link it in the description down below. And you can go download a copy of Boson Netsim. You can set it up in demo mode just like this. You can work through this exact same lab. And then from there, if this is a product that is useful to you, and we hope it will be, then you could purchase either the CCENT, CCNA, or CCNP version of Netsim. And that will unlock all of the technology and all of the labs for the version of Netsim that you've purchased. So if you have any questions, feel free to drop them in the comments down below. If you haven't already subscribed to our channel, we'd appreciate it if you do so. And we're always happy to get feedback and questions through the comments. We'll get those answered right away. And thanks for watching.